Assalamualaikum and hello everyone. I'm Norazlina Ridhwan from Universiti Malaysia Sabah. I'm here to present our research work about the Bambangan Seed Fat, the effect of the extraction solvent on the fatty acid composition and its crystal microstructure. So Bambangan has become one of the iconic fruit that is cultivated in Sabah, Malaysia. Bambangan is known as a wild mango, and for example, in Malaysia, it is only cultivated in certain places, such as in Sabah, and then it is come from the mango family, which is the Anacardiaceae, and distributed around the Borneo Island, such as the Kalimantan, Indonesia, Sabah and Sarawak, Malaysia, and then in Brunei. And Bambangan nowadays is well known for the antioxidant and the anti-cancer properties, so that it is utilized as a functional food such as the juice, processed food, health drink, and then used as flavoring ingredient, leaving the seed as a waste byproduct. And this seed actually composed of 9.8 to 11% of fat, 3.08 to 4.1% of protein, and then 38.68 to 72.9% of carbohydrates, indicating that this seed has nutritional potential as a protein and carbohydrate resources. And this is also reported previously by Jahbul et al. 2018 to have a high level content of antioxidant, so it is a healthy fat resources. So Bambangan seed fat mainly composed of the palmitic, stearic, oleic, and linoleic fatty acid that is leading to the presence of the high melting triacylglycerol, such as the SOS, and this SOS actually responsible for increasing the hardness of a soft fat. So it became as an interest for the researcher because it has similarities with the cocoa butter-like fat, such as the illy butter, mango seed fat, cocoa butter, salt fat, and then shea butter. Moreover, this seed fat is applicable as a SOS-rich fat resources to increase the hardness of the soft fat, which is these properties is desirable in a country with a high climate region. For the extraction of the Bambangan seed fat, the extraction actually can be performed using various ways, but in this work we use the sofflet extraction, where it is a economical and simple technique which allows several extraction to be carried out simultaneously, and it also has high oil recovery compared to the other method. And then the operational cost for this technique is lower because the solvent can be recovered after the extraction. So we can reuse the solvent for the another extraction processes. And the extraction can be performed using polar solvent and non-polar solvent, such as using the ethanol, hexane, and the petroleum ether. And the extraction efficiency is actually depending on the temperature, oil nature, particle size, sample pretreatment condition, time, and then the solvent type. So the choice for solvent for the extraction is very important because this is determining the quality for the extracted fat. And then there's also different study which reported how the extraction solvent influenced the oil quality, specifically the yield and then the bioactive compound level. But the fatty acid composition and the crystal microstructure for Bambangan seed fat extracted using different solvent is still unexplored area. So in this study, we extract the Bambangan seed fat using three types of solvent, which is the hexane, petroleum ether, and then the ethanol. So we wanted to determine what is the changes for these properties of this extracted Bambangan seed fat. So in this study, we want to determine what is the changes in the physicochemical properties, specifically the iodine value and slip melting point, and then the fatty acid compositions and crystal microstructure for the extracted Bambangan seed fat, as well as what is the efficiency of the extraction solvents. Official and established method, as shown in the slide, was used for Bambangan seed fat extraction and determination of the physical chemical properties. the fatty acid compositions and crystal microstructure of the extracted Bambangan seed fat. First, for the sample preparation, the seed was separated from the flesh and then cut into small pieces before dried at 45 degrees for 2 days and ground into powdered form. When the sample is ready, the Bambangan seed fat was extracted using Solvent extractor using 3 different solvents, which is the hexane, petroleum ether, and ethanol at 40 degree, and 50 degree according to the boiling point. And then the remaining solvent in the extracted Bambangan seed fat was evaporated using rotary evaporator. And then thirdly, the physical chemical analysis for the iodine value and slip melting point for the extracted Bambangan seed fat was determined using the American Oil Chemists Society official method using titration base and open capillary glass tube. And then lastly, the fatty acid compositions was identified using gas chromatography equipped with flame ionization detector, and then the crystal microstructure using the polarized light microscopy. For results and discussion, the discussion is comprised of the total fat content, the iodine value, slip melting point, fatty acid compositions, and then the crystal microstructure, and then what is the potential application for the extracted Bambangan seed fat based on their characteristic. This figure shows the physical appearance for the Bambangan seed fat extracted from the 3 different solvents, where the first picture shows that the hexane and petroleum ether extract is appear as a yellow liquid solution, while the ethanol extract appear as a cloudy brown solution when we melted it at 60 degrees, and then the extract turned into a yellow and brown solid fat at when we leave this at 25 degrees. So this indicates that the Bambangan seed fat has more saturated fat that is solidified at ambient temperature. The total fat content and the physical chemical properties for the extracted Bambangan seed fat is shown in this graph. And then among the extraction solvent, we can see that the hexane produces high total fat content, followed by the petroleum ether and the ethanol. So indicating that the hexane has a better efficiency for extracting the Bambangan seed fat. This is because of the low polarity properties in hexane that allows the rapid molecules transfer between the solvent, so it gives a higher total fat content. And then the physical chemical properties such as the iodine value and the slip melting point for the 3 extracts also influenced by the extraction solvents, where we can see petroleum ether extract has the lowest iodine value, followed by hexane and then the ethanol extract. So based on this value, we know that the petroleum ether has more saturated fatty acid. This corresponds to the slip melting point, where it has a higher slip melting point compared to the ethanol extract. The trends for the efficiency in the extraction solvent and the changes in the physical chemical properties is in line with the results reported by Kittipom and Sutasine 2013 and the JDD et al. 2020, where they report hexane that give a better efficiency in extracting oil and similar changes in the physical chemical properties. Next, the fatty acid composition. This table shows the changes in the fatty acid profile for the extracted Bambangan seed fat. And from this table, we can see that the stearic enolic acid for the 3 extract were significantly affected by the extraction solvent. And from this extract, we can see that the hexane and petroleum ether extract Bambangan seed fat has higher stearic acid, where it is resulting to the presence of the SOS triacylglycerol, as I mentioned before, which these properties makes Bambangan seed fat applicable as SOS-rich fat donor, and it is similar to the cocoa butter-like fat, such as the sulfate and the shea butter. And then the petroleum ether extracted Bambangan seed fat has higher palmitic acid and stearic acid compared to the ethanol extract, where the ethanol extract has higher oleic and linoleic acid, and these changes are explaining why the hexane in the petroleum ether has higher melting properties compared to the ethanol extracted from seed fat, because the oleic and linoleic acid is the unsaturated fatty acid, which has a lower melting properties compared to the saturated fatty acid. And then the changes in the fatty acid composition for the three extract can be supported by Kittiform and Sutasine 2013, where they report similar changes in the fatty acid profiles for the extracted mango seed fat using hexane, petroleum ether, and the ethanol. Lastly, this figure shows the crystal microphotograph for Bambangan seed fat extracted from hexane, petroleum ether, and ethanol. We can see that all of the fat structure showed a spirulite crystal consisting of needle-like that is branching outwards. And then this kind of structure is commonly associated with the beta polymorphic form of a cocoa butter, which is usually desirable for chocolate production. We can see from these three figures, the crystalline structure is significantly changed after the exposure to the extraction solvent, where petroleum ether and the ethanol extracted Bambangan seed fat has a compact cluster of fat crystals compared to the hexane extracted Bambangan seed fat. And then the spirulitic structure for the petroleum ether was disrupted after the exposure to the solvent, and then makes the structure become oval and compact, as we seen here, where the ethanol extracted Bambangan seed fat has smaller crystal structures compared to the hexane and this petroleum ether. And then the changes in the crystal microstructure is because of the variety in the textural properties of the fat, and also influenced by the saturation degree, which is mainly affected by the fatty acid composition. But overall, these three structure showed similar structure as the cocoa butter structure, as reported by the Sonwai and Popra Chenevert 2014. So again, I would like to highlight that this extract is applicable as a cocoa butter alternative. And finally, as a conclusion, I could say that the extraction of the Bambangan fat from the hexane, petroleum ether, and ethanol solvent was successfully carried out, and the results suggest that the hexane extracted Bambangan seed fat has better overall fat quality when we look at the high total fat content, and then it has similar iodine value and slip melting point with the petroleum ether extract, where both hexane and petroleum ether extracts showed similar fatty acid type with cocoa butter, but only the hexane extract exhibited a similar, less dense crystalline structure with the cocoa butter. So hexane is suitable for the extraction of Bambangan seed fat, and it is applicable as cocoa butter alternative because of the similarities with the cocoa butter, including the physical chemical properties in terms of the slip melting point, and then its fatty acid composition and the crystal microstructure. Alright, that's all about our research project. Thank you for listening and your time. For any inquiries, please contact me using this detail.